Okay, guys, we're going to do 2.03 notes, which are talking about the sum and the difference of cubes. Here's your formulas. You're going to want to make sure that you have written down somewhere so that you can have access to them. And we're going to be talking about how we can take cubic expressions and put them into these broken down factors, if you will, because that's what we're looking at. These are going to be factors of these original expressions, okay? And quite possibly we could end up solving them down the road, and we'll talk about that a little bit more, okay? One thing you got to know, our acronym is SOAP, same, opposite, always positive. What that basically stands for are the signs, okay? So SOAP stands for the signs. And what I mean by that is that we have the signs of our original problem. So this sign is positive. That means when we put out our factors of this original expression, the first sign will be the same, the next sign will be opposite, and then the last sign will always be positive. So if we looked at it from the difference of cubes, now instead of having a positive, we have a negative. So our first sign is still the same. Second sign is still opposite, and the last sign is always positive. So that's what SOAP stands for, as far as that little help of remembrance of what we need to do. So we're going to talk about perfect cubes. Like perfect squares, perfect square is the number multiplied by itself twice, if you will, squared 2. Cubes are going to be the number multiplied by itself 3 times. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So let's just look over here. What happens if my x, or my input, is -1? -1 times -1 is +1 times another -1 makes it -1. -2 times -2 is 4 times -2 is -8. So what you'll see is when this number is negative, it's just going to make it's going to be the same numbers that you have for the original cubics. It will just be negative because you basically have the same number, or 3 of them are odd number, -1, -1, -1. So it's 3 -1s. Hence, it's going to be a negative number. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6, 216. 7 times 7 times 7 is 343. 8 times 8 times 8, I believe it's 512. And 9 times 9 times 9 is 729. And 10 times 10 times 10 should be 1,000. So these would just be all negative numbers, or the negative expression of the same numbers. Not that big of a deal that you need to understand these right now, but you do need to understand the fact that if you multiply a number by itself 3 times and it's negative, you're going to get a negative answer for that. And I sure hope these numbers are correct, just because this is a video and I want to make sure. I'm pretty sure these numbers are correct, but I like to be ultra sure. So 8 to the third is 512, and 9 to the third is 729. Yay! I'm doing well, I'm doing well. Okay, so we're going to erase these, take a screenshot, zoop. You need to know them. Like, knowing them is crucial, because when we start doing perfect cubes, if you look at these equations here, what we're looking for are numbers that are going to be, or expressions, if you will, terms of them, that are going to be perfect cubes. If they're not perfect cubes, we can't use this, hence the equal sign. So perfect cube plus a perfect cube equals all of this when we break it out. Perfect cube minus a perfect cube equals all of this. So if these two original things are not perfect cubes, okay, whether it's a variable or a number, then we can't technically use this, because then it wouldn't necessarily be equal. So let's do a few of them. Yay! Practice factor the following expressions using SOAP. Okay? So if we look at this, the first thing we need to understand is this is kind of the equivalent of a cubed minus b cubed, because x cubed is a perfect cube, because to get x cubed is x times x, which is x cubed. To get 8 is 2 times 2 times 2 gives me 8. Well, this is equal to a same, a squared, opposite, AB always positive, B squared. So if we look at that, we simply need to understand that we need to determine A and B. We need to know what A equals what, and B equals, oh, I'm already writing numbers down. B equals what? We need to know those two. So if we look at this here, these are just representations of that A. So A cubed is basically equal to x cubed. So A would be equal to x. And then we have B cubed is equal to 8. Well, B times B times B, right? So if I have B times B times B equals B cubed, then 2 times 2 times 2 equals 8. Okay? So that means that B is equal to 2. You want a total breakdown, that's how it works. So now we just plug in my A, x, my B is 2, my A is x squared, my A is x, and my B is 2, and my B is 2 squared. So then when we simplify all that out, I'll rewrite it what I have in black. So my A is x minus 2. X squared is x squared. X times 2 we rewrite as 2x. And B squared, 2 squared is 4. And that's how you would write these things out like this. Okay? I'm going to go ahead and do 3 while I'm down here. If I look at 3, I notice that 250 is not a perfect cube. There's not one number that's going to give me this times this times this to give me 250. Same thing with x to the 4th, not a perfect cube. Same thing with 128. There's no number that's going to give me 128, and x is just 1x. So I'm going to recognize that I need to at least factor out an x. GCF, okay, is at least x. But I need to factor something else out because there's no way to get that. So if I think about it, if I divide 250 divided by 2 gives me 125, so that would give me a perfect cube. And 128 divided by 2 would be 64, which would also be a perfect cube. So my GCF is 2x. So when I rewrite that, I have my 2x, and I'm just going to write this as my original this plus that, right? But I got to do some canceling out. In the process, this cancels, and that becomes 64. That becomes x cubed, and that's 125. So while the 2x is out front, that didn't have anything to do with me. I'm going to leave that there for my final answer. Now I have perfect cube plus a perfect cube. I'm sorry, this is, I forgot my x cubed. Get my cart ahead of my horse. 125x cubed, okay? So each one of those are perfect cubes. So 125, or a cubed, equals 125x cubed. So a would be 8 times 8 times a. 125 is 5 times 5 times 5 times 5 times 5, which is 5. X cubed, x times x times x. So my a is 5x, and my b cubed is 64, which means b times b times b is b cubed. 4 times 4 times 4 is 64, so b equals 4. Okay? So now we just plug in. We got to remember, though, we have plus. So this is my same, opposite, always a positive. So I'm going to kind of jump at this, and so we set this up, but I'm going to redo it up here at the top in black. So we have x cubed, then we have a, which is 5x, plus b, which is 4. A squared is 5x squared, opposite. A times b is 5x times 4, always positive, 4 cubed. So now when I come down below, I have, this doesn't really change, kind of stays the same, 5x and 4. That is 5x squared, 5x times 5x, which is 5 times 5 is 25, x times x is x squared. So now I have 25x squared. 5x times 4 is 20x, and 4 times 4 is 16. That is my final solution. Totally factored out, and I could set these up as factors and solve for them. In other words, I could set my 2x equal to 0, and I know that one of my factors will be 0. One of my solutions will be 0. 5x plus 4, one of my solutions would be negative 4/5. And then I would have to use the little star method and the crisscross to determine what my other two solutions would be there. Again, the original problem is x to the 4th. That tells me how many solutions I have. 4 of them. 1, 2, 3, 4. When we factor those out. And we know how to do those, or we should know how to do those. Okay, let's go up here to the top. If I look at number 2, I recognize that there is 2 is not a perfect cube, so I need to factor that out when I rewrite that in its factored form. Now I have x cubed is a perfect cube, 27 is a perfect cube, so my a equals x and my b equals 3. And I plug in x, same, x squared, opposite, 3 times x, 3 squared. So my total answer at that point . That was pretty straightforward, not a big deal. Again, 3 solutions. 2 cannot equal 0. X is equal to 3, so that's one solution. And when you factor that, that would be, wow, that would be a funky solution. So that's going to give me x equals negative 3 twice. So it's going to bump. For those of you guys who care about that, this thing is going to look like this. So it's going to go at 3 and negative 3, okay? We'll give you some way cart ahead of the horse of where we're going. So this thing is going to look, and then it would be y, and y equals 0. It would be negative 54, so it would cross way down here at the bottom at negative 54. This is stuff we're going to be doing, guys. Way down here where x is, and it's going to look something like this when we shape it. When we start graphing these bad boys, that's what you're going to be looking for. And how did I know that my x is negative 54? Just to give away cart ahead of the horse, if I looked at my original thing, we set it equal to y. And to find my y value, I set my x equal to 0. So when my x is 0, my y is negative 54. That's why that point right there is at 0, negative 54. Yay! That's stuff we're going to be doing. Get ready. So I'm going to clear this up. I'm going to let you guys kind of look at that for a second while I erase some of this other stuff. But we're going to clear that up. You can pause it and rewind that bad boy if you want to. And we're going to look down here below. Now, obviously, 128, again, very similar to here. you'll start seeing the same numbers a lot. So I'm going to have to divide that by 2. And I know 2 is, so I'm going to divide that by 2. I can't have an x squared there, so I'm going to get rid of that too. If I get rid of that in the front, I'm going to get rid of that in the back. Recognition is everything to learning how to do these things. Cancel, cancel. That ends up with 1. 64 x cubed. So when I pull my GCF out, that's what the bad boy looks like. So now I am at A equals 4x, 4 times 4 times 4, and B equals 1. I'm not going to keep writing all that. Y'all need to, at some point, be able to do that. Y'all need to recognize that. I'm not going to do all those over and over again. So now my 2x is my A, 4x, same, B, A squared, opposite, A times B, always positive. So when I rewrite and simplify that out, my 2x comes out. My 4x minus 1, right? Yep. And then I have 16x squared plus 4x plus 1. If I look at that, why am I only getting it's going to be 0. So that's going to have a double solution somehow. Oh, I know what I did wrong. Hey, look at me. All right, so let me tell you what I just did. And you may have been yelling this all along, okay? In my mind, same thing I tell you from way back when up here. In my mind, after I get done, because this is where we're going, I know I have to have 5 solutions. 5. In my mind, I have to have 5 solutions. So before I wrote that there, I know that this is 1 solution, this is 2 solutions, this is 3, 4 solutions. So I'm going, wait a minute, why am I only getting 4 solutions? That's because I forgot that squared. And when you start getting good at this, and you start recognizing that, you'll start to see when you make mistakes before you actually hit the submit button, if you will, or actually turn things in. You'll get to that and be like, wait a minute, I'm supposed to have 5 solutions. And I'm down here, I got 4. Something went haywire. And again, what that means, when I talk about solutions, when we talk about solutions, with solutions of these things means where the graph crosses the x-axis. That's what a solution is. X equals. Where does x equal something? X equals. So if I look at these things, right, and I would set this equal. I set each one of these equal. Let's just do it. While we're here, let's just go ahead and knock this out and do it. I like to get way ahead so that students, when I get to it later down the road, they're like, dude already taught me, I'm good. So I'm going to set each one of those equal. 2x squared equal to 0. Even though there's no equal sign here, there will be eventually. Right now, we're just solving. So if I do that, x squared equals 0 divided by 2, which is 0. Take the square root of x is x. Take the square root of 0, it's 0. But technically, it's 0 twice. Why is it 0 twice? Well, like I keep telling you, that right there determines your solutions. If you have 0, if this was 4x to the 16th equals 0, you would have 16 zeros. 16 zeros. Okay, that's what that stands for. Here we just have 2. We go to this one, we have 4x minus 1 equals 0, so I have x is going to be equal to 1/4. And factoring this bad boy out is 16, which is going to give me Let me do this in my noggin real quick. I know I'm going to have this, and I know I have to have, they're both positive, this is 1, this is 1. So I got to figure out how I can get that to give me that. That one I don't think I can't factor that one. I'm going to use a quadratic equation for that one. Let me do it. We're here now, I'm not going to stop. Negative b plus or minus square root of b squared, which is 16 minus 4ac. 4a is 64, so negative 64, which is going to give me 2 imaginary solutions over 32. Negative 4 plus or minus, that is 48. Square root of 48 will be 4i root 3 over 32. Pretty sure I'm right there. 48. I am right. So what that means is we're going to have to be graphing these, and this one's going to be hard to graph. This will tell me I have 2 imaginary solutions and 3 real solutions. We're getting there. It's a lot going to happen. We're going to be dealing with all of this craziness down the road. The other 2 problems I did in class, so I'm not going to waste your time going through all those. I'll do them really quickly and just tell you what they are. Factor out a 5x here, right? And then I end up with x to the third minus 1, which this will be 5x, and x, same, opposite, always positive. That's how that one's going to go. Yeah, I'm pretty good at these. And there's no GCF here, so this will be 3x, same, 3x squared, opposite. Trust me, you have to do that. I have to do that. I have the same, opposite. I use SOAP all the time, at home and in math. 3x plus 4 is 12x, always positive is 16. Ding, ding, ding. So a lot of times I don't even define my A and B. I define them here, and then I know that's A and that's B. So square it, multiply the 2, square it. Ding, 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 ding. And that's that one. All right. Peace. It's Friday. It's late. I'm out.